So in this video we're talking about geometric sequence. Now before we talked about arithmetic sequence. So a geometric sequence has a different formula or a different rule than an arithmetic sequence, so be sure that you do not get the two mixed up. So a geometric sequence, the ratio of any term compared to the previous term is always constant. So the constant ratio is called the common ratio, and we call that common ratio R. So if you see an R, we're talking about common ratio. In these two examples, what we're doing is deciding whether or not the sequence is geometric. The way we're going to do that is just, again, we're searching for that common ratio. If it's got a common ratio, that means it is geometric. If it doesn't, not geometric. So a little bit of scratch work. So a ratio just simply means to divide. So what I'm going to say is 2 divided by 1, just scratch word, which is 2. 6 divided by 2, which is 3. So already these ratios are not constant. So that means it's not geometric. It's still a sequence, but it's not a geometric sequence. Okay, so now let's check the other one. The other one. Again, ratio means divide. So I'm going to say 27 divided by 81. Okay, so we can use calculator for scratch work. That's fine too, and it also saves a little bit of time. So just go to your main screen. 27 divided by 81 is, and let's do a fraction. That's probably going to be easier. So 1/3. Do a little bit more scratch work. 9 divided by 27 is 1/3, so that's good. And then last scratch work, 1 divided by, or sorry, not last scratch work, I'm skipping. 3 divided by 9 is 1/3. And then finally the last one, 1 divided by 3 is obviously 1/3. So here my ratios are all constant, so that means that, yes, geometric. Okay, again, if it has a constant common ratio, R, then it is a geometric sequence. And here's that rule I was talking about for geometric sequence. So the nth position of any geometric sequence can be given by the equation if you know the first position, the common ratio, and whatever position you're in, say the first position, the 10th position, etc. So that's going to be your n. So here in this example 19, we're going to write a rule for the nth term of the sequence. So this is a geometric sequence. And then once we have that rule, we want to go back and find who lives in the 8th position, or I like to call it the 8th house. Alright, so this is a geometric sequence. If you don't believe me, we can go back and find R. So we do that by dividing. So -12 divided by -8. Again, I'm going to use my calculator, save a little bit of time, I hope. So -12 divided by -8 is 1.5, but I want that as a fraction. So 3/2. And that's my R. Okay, so everywhere I see an R, I'm going to put in positive 3/2. And now what I want to do is to plug in what I know. So I know a sub n equals, now my first position, in the first position is -8, so that's going to go in for a sub 1. So -8 times my fraction, it goes in parentheses because it is a fraction, raised to the n minus 1. Now there's more than one thing there, so I'm going to go ahead and put that in parentheses, okay, just to be safe. Again, the n minus 1's up in the air, so I like to write out that little caret key, so because when I'm going to use my calculator in a few minutes, I need to remember to put that n minus 1 up in the air. Okay, now for the second part, we want to find a sub 8. So we're going to use this formula. This was the rule for the nth term of the sequence. So now I want to find the 8th term of the sequence. So here, n is 8. So that means I'm trying to find a sub 8, which is going to be -8 times 3/2 to the 8 minus 1 power. Again, that's up in the air. And I'm just going to type this in. So what I'm finding is in the 8th house, who lives there. Okay? So I'm going to just use my calculator now. Okay, so I can say negative 8 parentheses 3 over 2 raised to parentheses 8 minus 1. And I get a decimal. Let's turn that into a fraction though. Hopefully it'll turn into a fraction. I get negative 2,000. So a sub 8 is negative 2,187 divided by 16. I like the fraction a little bit better than the decimal just because it's a little bit cleaner. If you rounded this, say to 2 decimal places, you're not getting who really lives in the 8th house. So I would encourage you, please, 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 put it as a fraction. So again, in this example, it was a 2-part problem. We had to first make the general rule that we did in blue, and then once we had that general rule, we were able to use that rule to find any position in the sequence that we wanted. In green, we found who lives in the 8th position. So we did our scratch work and found that negative 2,187 divided by 16 lives there. Okay. All right, so now we're going to move on to another example. This is example 20. So one term of a geometric sequence, it's actually in the 3rd position. We know that's 5. We also know that the common ratio is 2, and then now we want to write a rule for the nth term of the sequence. Well, since we know that it's geometric, we know that the nth term is given by a sub n equals a sub 1 times r to the n minus 1 power. Again, that power is up in there, so I like to do the power key. Also put your power in parentheses since there's more than one thing there. Now, we know that when n is 3, that a sub 3 is 5. Okay, so that's what we know. We were given that in the problem. So what I want to do is use that information and plug in. So so I know 5 is equal to my first position, which I don't know yet, times my common ratio, which is 2. I was given that, raised to the 3 minus 1 power, because we know if we're using 5, we're in the 3rd position of this sequence. All right, so now what I'm going to do, this is kind of complicated, so I'm actually going to use my calculator to help me out. Instead of a sub 1, I'm going to actually pretend when I use my calculator that a sub 1 is going to be an x. That's what I'm going to type in for a sub 1. So just keep that in mind. We're going to graph now. y1 on the left, y2 on the right. Just remember, instead of a sub 1, we're going to type in x. So I go to y equals, clear out all my other stuff that's there. So 5, and then x parentheses 2 parentheses raised to the 3 minus 1 power. Graph it. Okay, and I see I have a point of intersection, so that's what I'm looking for. Second calc, option 5 for intersection. First curve, you just hit enter. Second curve, you just hit enter, and then guess. And so I get that x is 1.25. Okay. So x is 1.25. Now I'm going to go to my calculator, the main screen that is, and type in 1.25 because I want that as a fraction. So x is 5/4. When you're doing these arithmetic and geometric sequences, you always want to work with fractions. You don't want decimals if you can help it. Now, instead of x, remember I was pretending that x is equal to a of 1. So really, this means that my first position is 5/4. Now that we know what our first position is and we know what our common ratio is, we can finally answer the question and write an equation for the nth term. So again, I'm just using this model. I'm plugging in what I know. So a sub n equals 5/4. That's a fraction, so I want to put in parentheses for our common ratio of 2 raised to the n minus 1 power. So this rule right here will let us find any member of this particular geometric sequence. Okay? Again, 5/4 was our who lives in the first position of the sequence. The common ratio is 2, and then we just raised to the n minus 1 power. All right, and then our last example of this video, here we are given two terms of a particular geometric sequence. We're given the second position has a 45 in it, and the fifth position has a negative 1,215 in it. We want to find a rule for the nth term of the sequence. Well, again, since it's geometric, I know I'm going to start off with a sub n equals the first position times the common ratio raised to the n minus 1 power. Okay, now I'm going to plug in the information that I have. When n is 2, I know that a sub 2 is 45. So I'm going to use that information and plug into this rule to get 45 is equal to the first position times r to the 2 minus 1 power. Okay, because I'm just plugging in what I know. I also know that when n is 5, that a sub 5 is negative 1,215. So I'm going to plug in what I know to my general rule. So I have negative 1,215 is equal to my first position times the common ratio raised to the 5 minus 1 power. Okay? Now, before I can go any further, I'm going to graph, but I got to pretend a few things. First off, I want to call x my first position. I'm going to call y my common ratio. So that means I have a system of equations, which you should have done system of equations in previous classes, maybe not using equations this complex, but the idea should still be the same. So my green equation becomes 45 equals x, y raised to the 1 power. Okay? And I also know that trying to think if graphing is going to be a good idea here. Probably not. So scratch graphing, forget that. Sometimes you just have it's like a light bulb goes off in the middle of a problem. You're like, what I'm doing is not going to work. Since these are so complicated, I was thinking about how are we going to get y by itself to graph? And since these are such complicated problems, or such complicated equations, I should say, getting y by itself is going to be pretty tough. So instead, what I'm going to do is do some scratch work with the green. So again, I'm just working with the green equation, and I want to simplify where I can. 2 minus 1 is 1. So this is what I have when I clean up. Now, I'm going to use this information. We know that anything to the first power is itself, so really this equation becomes 45 equals the first position times the common ratio. Well, let's go ahead and get one of these things by itself. I want to get the common ratio by itself. So I'm going to divide by my first position, a sub 1. So that means everywhere I see an r, I can put in 45 divided by a sub 1. Everywhere I see an r, I can put in 45 divided by a sub 1. Okay, so now that I have that, I'm going to substitute into the red equation. Everywhere I see an r, I'm going to put in a 45 divided by a sub 1. So I have negative 1,215 equals a sub 1 times r, but again, r I'm just substituting in 45 over a sub 1 and I'm going to go clean up 5 minus 1, which is 4. Okay. So now I want to use my calculator to help out. First off, remember when I have parentheses and the power on the outside, it's like sharing the power. So both pieces of my fraction are going to get this fourth power. So really what I have is negative 1,215 is equal to a sub 1 times 45 to the fourth power over a sub 1 to the fourth power. Okay? Let's figure out what 45 to the fourth power is. I'm only going to tell you it's going to be big, so don't be intimidated. Which is, looks like 4,100,625. So negative 1,1215 is equal to is equal to a sub 1 divided by a sub 4 times, I lost my calculator, there it is, 4,100,625. Okay? Now, check it out. I've got a sub 1 to the first power divided by a sub 1 to the fourth power. Let me write that correctly. So, when I'm dividing the same base, my base is a sub 1, this is a sub 1 to the first power, I subtract the powers. Okay, so this is going to be negative 1,215 equals a sub 1 to the negative 3 power times 4,100,625. Now, I want to get a sub 1 by itself, so I'm going to actually divide by 4,100,625 on both sides. Cancel out. So I have a sub 1 to the negative 3 power is equal to, let's get whatever fraction this is. I'm just going to use my calculator. Hopefully that fraction will reduce some. We'll see. So negative 1,015 divided by 4,100,625 is a decimal. Let's try to turn it back into a fraction. Unfortunately, it doesn't reduce, so that fraction is as good as it's going to get. Alright, so we have negative 1,215 over 4,100,625. Now, I don't want negative third power. So what I'm going to do, I'm going to think of this power as a fraction, negative 3 over 1, and to get rid of that fraction, I have to flip it. So I want to use the, and I also have to use, since it's negative, so I'm going to flip this fraction to a negative 1 over 3 power. You have to do that on both sides. That's something you should have done in a previous class. So what's going to happen with these powers is negative 3 over 1 and negative 1 over 3. They're going to cancel out, so I'm just going to be left with my first position is equal to this, whatever this is going to be. So let's use the calculator again. I'm going to type in that fraction, which I've already done, raised to the negative 1/3 power. And I get negative 15. So in the very first position, I have a negative 15. That was a lot of work. Don't be intimidated by that. So now that I know that my first position is negative 15, I can go back here to where I see my first position, which is negative 15, and say that R is going to be 45 divided by negative 15. So my common ratio is going to be negative 3. As soon as I know both my beginning position, a sub 1, and my common ratio, I can finally answer the question and say, what is this geometric sequence? So my final answer is a sub n, which is equal to my first position, so negative 15, times my common ratio of negative 3 raised to the n minus 1 power. Lots of work, and I know that might be hard for you, but honestly, this is Math 3, so you're kind of expected to be able to do that by now. It's going to take time, and it's going to take practice, and honestly, you probably will struggle a little bit, but I'm here to help you, so if you got questions, let me know. And that's it for this video.